When you want to buy something normally, using your normal bank card, this is what happens. I give my card details to the shop asks the bank if I'm good for the money. The bank checks its records to see if I've got enough in my account. If I do, it lets the shop know. It updates its records to show the movement of money from my account to the shop's. Oh, and it takes a little cut for its trouble. Now, if you wanted to remove the bank from that system, who else would you trust to keep those records and not alter them or cheat in any way? Well, I wouldn't trust you. I wouldn't trust you. In fact, I wouldn't trust any single person. But I might trust everyone. The idea is you don't have a central record of transactions. Instead, you distribute many, many copies of this ledger around the world. Each owner of each copy records every transaction. So there's no way that a forged transaction can make it in. If I try to alter a ledger, it won't match all of the other copies. And it gets rejected. So, to buy something using cryptocurrency, I give the shop my details. The shop asks all the bookkeepers if I'm good for the money. The bookkeepers all check their records to see if I have enough. If I do, they tell the shop, and then all update their records to show the movement of money. Oh, and one of them, at random, will be given a reward of some newly created cryptocurrency. This is how cryptocurrencies work. And remember, all of these bookkeepers, all of these ledgers, they're not actually people. They're computers. Lots of computers. And I mean a lot.
That random reward for being a bookkeeper is an important point. It was the original incentive for people to use their home computers to help keep the books. But I feel the scale of these places is tipping the odds away from average investors.
Every single one of these is a desktop computer. There are thousands of them, all wired together and all doing one thing. Bookkeeping for cryptocurrency.
And because every so often they get that reward of new cryptocurrency, they call this operation mining. Now, this particular mine contains 20,000 machines, a very expensive setup.
As well as the cost of all of this hardware, running an outfit like this also costs a lot in electricity. That's not just electricity to power the computers, but also to power the cooling systems to stop this lot overheating. That's why they put this one in Iceland.
Like a lot of mass computing operations, north is best. It means you don't need to run energy-hungry air chillers. You just suck in that freezing air from outside. Oh, and the electricity here is geothermal and really cheap, thanks to the volcanic activity just underground. Despite all of that, though, this place spends more than €1 million a month on electricity. So you can imagine how much money they're making.
Okay, so you watched the video. It's just an illustration of how crypto transactions work and how records are kept. And basically, we've said that the records are not kept by humans; the records are kept by computers. Right. The reason why we are giving this background is for you to understand, before we go into cryptocurrency itself, is because this is the technology that supports crypto. And for you, when you understand it, you understand the formidability, you understand the strength of the technology itself. Right. Now, kickstarting today. We've started with that video, so we'll talk about the characteristics of blockchain, right? The 4 major characteristics of blockchain. 4 major. Number 1, trust. Number 2, immutability. Number 3, security. And number 4, disintermediation. Now, so these 4 things, let's just explain it a little bit in simple English so all of us can understand characteristics of the blockchain. Now, number 1, we said trust, right? Now, as in the illustrative video, you know, when one person is the person keeping records of transactions, it is easy for that person to steal stuff. Right. Recently, they were talking about a documentary of, I think it's Disney or somebody, that stole billions of dollars from Nigeria, bought a yacht that celebrities rent out. Now, it doesn't make sense. The reason why we can scream and say money is missing in the country is because the records are kept by a few people, and then the few people can agree or connive to do whatever they want to do. But so we cannot trust that system. The strict governing rules, cryptography, and the immutable transactions work together to provide strong security for individuals interacting directly on the distributed network without a central trusted authority. So we are no longer trusting one person. The power of the information and the technology is distributed to multiple people, so it is easy to trust that. And you're not even distributing it to human beings, you're distributing it to computers. So individually, standalone, everything has to correlate. If it doesn't correlate, it's not going to work. So now, the blockchain now allows us to trust. Normally when you want to buy something, the reason why you need receipts and the reason why we're doing all that is to generate or manufacture trust, because you don't know the person, because of humans. So blockchain has eliminated that. Now, immutability, that's number 2. Immutable transactions are recorded. When they say something is immutable, it means it cannot be tampered with. You get, it cannot be tampered with. It cannot be undone, or you cannot expunge it. You cannot change it. The moment it's done, it's done. You cannot reverse. I think reverse should be the word. The immutable transactions recorded on a blockchain cannot be changed or removed. To change a transaction on a blockchain, a new transaction needs to be added to reverse the effects of the original. Now, even though a new transaction is added, it reverses the effect of the original. But that original one cannot be deleted. Do you understand now? So in immutable ledgers, there is no way to expunge the record of a transaction. Even though that one is done, it's like you mistakenly transferred money to somebody. You wanted to transfer 1 million and you mistakenly transferred 10 million or 100 million. You can transfer the money back, right? But the record of the transaction is not expunged. That is what immutability means. You cannot reverse a transaction. You cannot take it out. When it's done, it's done. That's in crypto space. So one of the things you're going to learn, we're going to learn in this class, is that you have to be very careful with crypto transactions. There are things that when you do, you cannot undo them, because it's because of the immutability factor. You cannot undo some things. Okay, so the next thing, security. Number 3 is security. The use of encryption algorithms. Right, we're going to talk about that. The security of this system. There's something called cryptography. So everything in crypto or blockchain most of the time is encrypted. Now in crypto, the reason why it is encrypted is because there is need for anonymity, for incognito mode, for you not to know who the person is. That's the idea. You don't know who it is, so you don't attack the person, right? So the use of encryption algorithms combined with the disintegration of data across distributed networks provides security against attempts to destroy or change the record of transactions. So if everything is stored in one place, if it's stored in central bank server, if you destroy central bank server, it's gone. But if it is stored in multiple servers across the world, then you cannot do anything about it. Now then disintermediation. Now it is just removing, forget the big word, it's just removing central bodies. There's no need for intermediaries. So the way crypto is done now is that I just send you 1 Bitcoin, you send me USDT, or I sell it, the transaction is just done. There's no, we are not using Western Union. It's irrespective of the country that you are. We don't need to use intermediate. You don't need banks. You don't need people, unnecessary stops along the line. Okay, so it reduces risk of error that usually come with extra transactions in a system, right? Now, so let's go. Now we're going to talk more about crypto. We've been talking about the blockchain, so now we're going to talk about cryptocurrency, right? So in just simple terms, yeah, a cryptocurrency is a digital currency which is an alternative form of payment created using encryption algorithms. Let's stop there. So a cryptocurrency is a digital currency which is an alternative form of payment created using encryption algorithm. Is that simple? Okay, very, very simple. Now, this is it. Is a currency like naira, like dollar, but it is a digital one which is an alternative form of payment. So you can use it. It is some sort of legal tender, because legal tender is what people agree upon and they say this is what we're going to use. So globally, people have accepted it. So it's an alternative form of payment created using encryption algorithms. Now, because it is digital, it is not encrypted. Okay? Now, so the use of encryption technologies means that cryptocurrencies function both as a currency and as a virtual accounting system. I told you that the blockchain, basically, when we talk about the blockchain, we're talking about record keeping in multiple places, distributed ledger technology. We're talking about record keeping in different places. So accounting system that is virtual, but it is distributed. Now, so cryptocurrency, two words put together, crypt, currency. Now, crypt coming from the word encryption. It means to encrypt. Encrypt means to mask something, right? Like to cascade, to change the form, to secure something that is you won't understand. Before you're able to see it or read it, you have to decrypt it. So you have to unravel it. It's like a puzzle. Fantastic. It's like a puzzle. So a puzzle allows you to send a message that someone cannot understand. Right? So it's just a type of currency that is encrypted. So a type of currency that is secure, a type of currency that is protected. That is what cryptocurrency is. So what we are doing, what you have is money. Now, cryptocurrencies have also been considered as digital assets. Now, they are assets the same way people buy dollar and keep in Nigeria. You buy dollar and keep, and then because you're storing your money in that value because of what do we call that? Inflation and devaluing of currencies and things like that. So people store money in dollar. It's the same thing. People can store money in cryptocurrency as what do we call that now? They're now called assets, digital assets, right? Okay, I think you followed me to this point too. All right, so there are multiple cryptocurrencies. There are thousands and thousands of cryptocurrencies. It's something that we should have checked. We can even check on CoinMarketCap. There are thousands and thousands, tens of thousands of cryptocurrencies, and a lot are still being launched on a daily basis. We'll talk about some of the cryptocurrencies that some are a waste of time, some are genuine, some are scam projects. We'll talk about that in this class. Okay, so now let's talk about that cryptography we talked about, cryptography. Now, so cryptography is a method of protecting information and communications through the use of codes. So now, what is the idea is, this is an information that anybody can open. It's an information that should be open, but because you don't want that, people have done that in war. People have sent messages. That's where you started hearing about Morse codes. Now, Morse code is something somewhat of somewhat a system of encrypting information, so people don't know what you're saying, but the person there that understands Morse code, the person will be able to decrypt it. So now, as we said, communications through the use of codes, so that only those whom the information is intended can read and process it. So the prefix script means hidden or vault, and the suffix graphy stands for writing. So it's encrypted writing. Right? I study computer science, so I know a bit about these things. So don't worry about all the English. It's just protected writing. So that's what I was talking about, cryptography. In computer science, cryptography refers to secure information on communication techniques derived from mathematical concepts and a set of rule-based calculations called algorithms to transform messages in ways that are hard to decipher. So it's going to, that's basically what I was explaining, right? So it's closely related with disciplines of cryptology or whatnot. So, however, in today's computer-centric world, cryptography is most often associated with scrambling plain text. Basically, that's mostly what we do with it. Okay, so in cryptography, this is the process, how it works. So you write a plain text, it is encrypted. Now it becomes a ciphertext, non-readable format, which is encrypted data. So the plain text is the readable format, it is not encrypted, non-encrypted data. Then there is encryption, then there's the ciphertext, which is non-readable format. So for you to read it again, you have to decrypt what is encrypted. So there's decryption and there's encryption. Encryption is encapsulating it. Decryption is unraveling it for you to be able to read it. Okay, so there are a couple of things okay about it. These are the things that makes cryptocurrency secure. Now, which is these 4 factors: confidentiality, integrity, non-repudiation, and authentication. Right. So, with my little knowledge about cybersecurity, encryption is a lot, like a lot. Now, why should it be encrypted? Why should stuff be encrypted? Basically, that's what we're saying. Now, it should be encrypted because of confidentiality. It should be encrypted because for integrity's sake, non-repudiation, and authentication. Right. So let's talk about them. Now, confidentiality. The information cannot be understood by anyone for whom it was unintended. So if the information is not for you, then you will not understand it. That is, so it makes it confidential. Confidential, like when you say you're discussing with somebody confidential matters, it means the person should not discuss it with somebody else that the information is not intended for. So the confidentiality, that's the essence of encryption. That is why we keep saying if you can hold crypto and nobody will know your actual worth. That is why nobody knows Satoshi Nakamoto that we're talking about. Nobody knows the wallet that is holding the highest number of bitcoins till today. Confidentiality. Integrity. Now, the information cannot be altered in storage or transit between sender and intended receiver without the alteration being detected. So this is what it means. If information is stored or a record is stored, right, for integrity, now for encryption, now talking about integrity, if by the time you're trying to send the information from one point to the other, it's like what do we call it? It's like you sealed a paper. So something that is sealed, if you open it, you see something they'll say, return if this seal is broken. That is what they are trying to say, integrity. So you cannot alter the information or what is there without being detected. So first of all, it should not be altered. And if anything happens to it, you should know. Okay, that's integrity. That's why encryption is there. Then non-repudiation. The creator or the sender of the information cannot deny at a later stage his or her intentions in the creation or transmission of the information. So if you did it, you cannot deny it. Right? Like story in our class. It's not that type. Like we were in secondary school and were there, and then everybody started perceiving a foul smell, and then people were just saying, who was it who polluted the air and whatever. And then one lady said, if you did it, say you did it. If you didn't did it, say you didn't did it. Now, but then at the end of the day, This I've heard this story in different places, but it actually happened in my class in school. Now, but in non-repudiation, the creator or the sender of the information cannot deny. So if we had encryption there, and then you could decipher that this is the sender, or there is a sender of the information, the person cannot deny it. That is why encryption is there. You cannot deny it. I told you about blockchain technology. When we're talking about the characteristics of the blockchain technology, we spoke about non-repudiation. Yes. When we were speaking about the characteristics of blockchain, we said it cannot be reversed. When it is done, it's done. You can do another one to correct what you've done, but the record cannot be removed, right? Then authentication. Authentication, the sender and receiver can confirm each other's identity and the origin or destination of the information. Now, when I say confidentiality, and I was speaking about anonymity, when this authentication, I mean, doesn't mean that you will know who it is, but the sender and receiver can both confirm. So there must not be a name to the sender or the receiver, but there's acknowledgement of transactions that are happening with on what do we call that now? On encryption, on cryptography, right? That's why we're here on cryptography. It's basically that one must happen. Okay. Let me see. It's not the end of the slide. Sorry about that. Okay, right? So as I was saying, sorry, our slide went back. Okay, yes. So confidentiality, integrity, non-repudiation, and authentication. Basically, I really like to call it authenticity. Authenticity. Now, the next thing I want to talk about is transaction execution, right? And then the concept of decentralization. Now, the reason why I'm talking about transaction execution and the concept of decentralization is this. Okay, yes, you can hear me. So when projects, when there is a transaction on the blockchain, like the way transactions are executed is that, with the example of the video that we played, where you want to send an information, but then you initiate a transaction, and then there is a lot of nodes, computers, those that are mining, are doing a lot of calculation. So a calculation is going to be done. Now, after the calculation, the node or the computer that gets it right validates the transaction on the blockchain, and then that computer is rewarded. Do you understand? That computer is rewarded. Okay, so just in just a few seconds, let me just pick one of my notes to show you, to break down what do we call that now? Transactions. I don't want to use. Okay, so by the way, there's something I wanted to tell you also. I wanted to tell you that there are different types of blockchain, right? There are different types of blockchain. There is the, what do we call that now? There is the private blockchain, there's public blockchain, and there's hybrid blockchain. Okay, there's private blockchain, there's public blockchain, and then there is what do we call that now? Hybrid blockchain. So private blockchain is the type of blockchain that can be used by, what do we call those people now? It can be used by an organization. They can build their own blockchain and they're using it within the organization. Okay, then there is this other blockchain now. Which one did I say? Public. Most of the time, like crypto transactions. Okay, crypto transactions are public blockchain. That's why any transaction that anybody has, that's why we can go and then we see everybody, every transaction. We go and look for, what do we call them now? We look for wallets. Exactly, that's what I wanted to say. We look for wallets that have cryptocurrencies in them, and we can see them. Anybody can see, and you can see every transaction that is going on with that blockchain or with that wallet. So that is not, it's not hidden. So public blockchain, everybody has access to a public blockchain. Everybody has access to a public blockchain, right? So now let me now talk about what do we call that now? Transaction execution. I started talking to you about transaction execution. Now, transaction and execution has some stages. Let me see if this is showing, just to be sure. I want to be sure you can see my screen though. Let's not assume. Okay, can you hear me? It's showing me that I've left. I trust that I'm still in the meeting. Okay, so transaction execution. Okay, transaction execution. Now, the not transaction execution, transaction flow. Yeah, transaction flow. Right. So how is a transaction initiated and executed generally on the blockchain? So this is it. This is simply how it starts and how it ends. Okay, so after this, I think talk a little about the concept of decentralization, and then by tomorrow we'll start how to buy and sell cryptocurrencies, different networks and things like that. So for today, now this is the second to the last thing we're talking about. So transaction, it starts with transaction proposal, transaction validation, transaction execution, transaction confirmation, and then update. Transaction proposal, transaction validation, transaction execution, transaction confirmation, and then it is updated. All right, now so let's stay on this and we'll explain them. So what's transaction proposal? Right, what's transaction proposal? Transaction proposal is you have a crypto wallet, for instance a Bitcoin cryptocurrency wallet, right? That particular transaction does not go to a central entity because there's no central entity. Rather, it goes to all the participants who are there in the network. Are you following me now? A crypto transaction does not go. So normally when you want to do a transaction with your bank, what happens is that you just carry your, what do we call that now? Your card, or you want to pay, and then your bank asks, do you have the money, and then you are paying. Basically that's that. But on the blockchain, crypto transactions, the way they work, it is when you propose a transaction, that's why it's called a proposal with your wallet. It doesn't go to a central body. There's no central entity. It goes to all the participants who are there on the network. All the nodes, all of them, they go on. Millions of them, they just go to them at the same time. Now, so then it goes to the next stage. This is transaction proposal, yeah? Then we go to the next stage, transaction validation and propagation. Now, transaction validation, all the participants in the network validate the transaction. Now, the transaction validation or all kinds of validation always happens against a reference. So all the participants in the network keep a reference copy with them against which they will be validating the newly proposed transaction. Because I told you, it's a record that all of them have. So all of them are going to cross-check with their own to see if it is correct. Do you have that amount? Is it true? Why do you want to send 60 Bitcoin? Do you have 60 Bitcoin? So once they consider it valid, they will be propagating it here to the adjoining participants who are there. It's as simple as that. Now, these participants won't trust each other. They won't trust each other. They will now validate the transaction with the reference copy that they have independently without the influence of each other. Do you understand? So every node is going to cross-check with its own until it validates it. So the reference copy will cross-check with all the history, all the historical transactions. So it will check with all the historical transactions that's happened previously and make sure that it is correct. All these things happens in milliseconds, all of them. So once it is considered valid, then we'll move to transaction execution. But if it is not valid, the transaction is going to halt there. So when it is the transaction execution, then once the process is valid, taken care of, then the transaction execution phase starts. There is a special kind of participant going to take care of this execution part. So there is a special kind of participant that takes care of the execution. So because of the blockchain ideology, everything is happening. The ideology of blockchain is that nothing should be happening in a centralized place, in a centralized fashion. It should always be happening in a decentralized fashion. So rather than having one entity take care of the transaction execution, there are many of such participants who are collecting these transactions. So there won't be just one transaction happening on the network, you understand, at a given time. Many transactions are happening. So there will be thousands of transactions that are happening on the network at any given time. So these special participants are collecting these transactions and then they're trying to form a data structure that is called a block. That's why we have blockchain. So many people are working at the same time. Somebody is still doing his own and then the transaction will be done, right? So a block is now formed and then it is recorded. The transaction is recorded on the block. I can go on and on about this thing, but I don't want us to talk too much. Now, these special ones that are trying to execute, they are like going into a competition because the one that actually finally executes it, the person is getting a reward. That's what miners get. There's something called crypto mining. Okay, fine. So now then there is confirmation of updation. So once a particular block is considered valid by a network participant, they will add it to their own reference copy. Now every other node, every other one will add it to their own. They will now add it to their own reference copy and will propagate it ahead to other participants in the network. So this thing will happen independently without the influence of each other again. So they will validate it by themselves. So all these things are happening by computers, right? Computers, right? Now, so with that, okay, we'll stop here today, and then tomorrow we'll kick off from wallets. We're going to kick off from wallets. So when we know what wallets are, what's centralized, what crypto wallets are, and then we'll now go into how you can create a wallet and then start your own crypto journey, create your wallet, learn how to buy and sell. There are different ways to buy. You can buy from centralized platforms, you can buy from decentralized platforms. So we'll show you all that, and then we'll stop that there tomorrow, and then hopefully we'll stop where we can stop this week. Today is what, Tuesday?